Thanks, Maggie. So just a quick introduction. My name is Shuchi Dikshit, Vice President Technology, American Express. In this role, I'm responsible for driving engineering solutions and different strategic priorities, including digital transformation for the finance organization. Also a champion for inclusion and diversity initiative for American Express Technology India. So a subject very close to my heart. So this team, the technology team over here, really enables the Amex organization around the globe to achieve the business objectives by engineering and designing a variety of technology solutions. So we work across a very, very broad range of technology stacks, covering different segments like data engineering, core engineering, web, mobile, cloud, infrastructure, and many, many more. So that gives an opportunity to really experiment with a lot of open source, new tech stacks, full stack. So we really encourage a lot of, participation in these kind of events. So extremely happy to have this group of women engineers participate in this session. It's really a great opportunity to enhance technical core skills and also develop innovative solutions. So would really like to congratulate you for taking the initiative to participate in this forum. In today's session, of course, you'll be learning about the core concepts of open source API in general as well. And if you think about it in today's context, today's technology world, speed to market and agility is of primary importance. So, and APIs play a very critical role in enabling that. Creating nimble and very sophisticated solutions at enterprise level. So basically, if we talk about, API, it's really a way how software components talk to each other. So probably you already have exposure to APIs as part of your projects and assignments that you would be doing as part of the curriculum. This particular session will help understand some of the core concepts as well as the application of APIs as you go through your learning journey. So with that, I'll just turn it over to Sheshadri to take us through the details of the concepts. Okay, so over to you, Sheshadri.
Thank you very much, Shuchi. So let me just share my screen. Right. So is my screen visible, Maggie? Right, okay. Right.
Sorry, I was on mute. Yeah, your screen is visible, Seshadri. Yes.
Right. So my name is Seshadri Gopalkrishnan. I work as a senior engineer with American Express. I've been here for about 9 years now. I've got overall about 22 years of industry IT experience. And as Shuchi explained, the topic of today's talk will be around APIs, specifically around open source APIs. Now, so I would be talking about how open source plays a big role in systems integration technologies via APIs. What are the standards and what is the tooling that's involved? And right. So I will be giving you an overview. I'll be starting with APIs. I'll be starting with APIs as a programming construct, application programming interface. And this is something that all programmers in colleges will be very familiar with. So starting from there, I would be talking about the evolution of systems integration over the last 2 decades, how the need to integrate different systems, different complex systems over different protocols and different widely available protocols has basically paved the way for the standards as they exist today, right? So I'll be talking through to you about interfaces, simple programming interfaces, then how they evolve to remote procedure calls if 2 different programs need to talk to each other over different processes or in a distributed sense. and how that paved the way for a service-oriented architecture style or the paradigm of systems integration. And eventually that moved over to a much simplified model called REST. And so the point number 4 is where I will try to focus on mostly. And so if you're working on a Codeathon right now, and if you are building some functionality, and I think you're working something called e-voting. And so if you're going to be integrating with some public sites like the Government of India sites for Aadhaar or something, or if you want to integrate with Facebook or Google, right? So you will be using REST APIs, right? So I will talk in detail about that. And also you will have to understand something around authorizations, right? So when you access the APIs to get the details about some user, you will need to have some authentication mechanisms in place, right? So I will talk about that as well, right? So seen simply as a programming construct, right? An application programming interface, basically it's just a set of methods, right? That some particular program exposes, right? Why do you need interfaces? So if you don't want to write a large monolithic program, right? You want to write programs that call other programs, right? A client program that calls a program which has got some functionality, then you need to break them into separate components. And the only way a compiler can understand how to compile, which methods I should call of the larger program is if that other program is declaring what methods are exposed and what are the parameters and what are the return types, etc. Right? So either if you are statically linking your smaller program to the larger program, or if you are dynamically calling it through a dynamic link library, right? So then you will definitely need an interface, right? So that is a concept around an interface, and where the objects, they define interaction with the outside world, and the methods of the object, they form the interface. Right? So this is something that I'm sure that you're all familiar with from your programming language. So if we extend this paradigm that, okay, now I've got two different programs and I'm calling it a client and a server. A client program is one that makes out a call to a server for some functionality, right? So say the simple date time functionality. So it says, okay, give me the date and I will give the date time, right? But the functionality is sitting in server, right? It could be on the same machine or it could be on a different machine. So essentially there are two different processes. So now your code has to run, right, over the network, right? So which means that now you need the ability to make a call over the network, right? And there's a lot of TCP/IP stuff that goes on over the network. There's a data marshalling and unpacking and unmarshalling, right? And as a client, you want to be remote from all of this, right? You want to write your client code should look simple, right? So this is how the inter-process communication and remote procedure call technology started about 2 decades ago. And Microsoft was a very big player then, right? So the DCOM, distributed COM, was essentially Microsoft RPC, right? And in the Java world, RMI was big. So they both had the similar kind of process where the underlying communication protocol is taken care of by that particular technology, right? So DCOM, so Microsoft, you would compile the code, and the Microsoft libraries would take care of all the communication protocol happening between the client and the server, right? So if you have an interface like what you saw on the previous slide, right? A vehicle has got certain methods, right? And so in the Microsoft world, you would provide this in the form of an interface definition language and compile it. And the client will then be able to call those methods locally as though those methods are just existing in the same program, right? All the complexity of marshalling all the data and transferring it over TCP/IP to a remote location is taken care of by the underlying Microsoft libraries. And Java remote method invocation had the same concept, right? Corba also was there. Corba is a standard object request broker. And it also had so the standard was developed by the object management group, and but the Corba standard was adopted by other companies, and there were many tools and technologies around it, right? So the reason why this didn't hold for too long is because the internet was getting really popular around the early 2000s, really growing. And all the complexity of managing security over internet firewalls and insecure machines was not really viable, right? So some mechanism was needed for communication over HTTP that was more open source than vendor specific, right? So the industry kind of quite widely adopted what is called a service-oriented architecture paradigm. And when I joined American Express about 9 years ago, I was one of the architects that laid the foundation principles for service-oriented architecture in American Express. And so the paradigm here is that it's a shift in thinking. Assume that you've got not small programs, but large systems, right? And these systems need to talk to each other, but view these systems as implementing a set of services, right? So there could be a shopping cart application, right? But think of it as a set of services offered by that application, right? And they're all talking to the respective databases. So, the thought process that you're able to view your different systems as providing a set of services, and then as different client applications or other services can consume other services. So there are multiple services are talking to each other, right? And all the service communication is happening through something called an enterprise service bus, right? And so the technology that was the paved way for this was basically SOAP over HTTP, right? So SOAP is simple object access protocol. SOAP is again it's again a standard, right? It's just a standard, and there was a lot of tooling from different large companies like IBM, and so they provide the tools necessary to be able to consume and to be able to serve SOAP messages from one system to another. And the transport, of course, was HTTP, right? So over the HTTP protocol, what is going on over and above it is SOAP messages. These are XML messages with a particular format. So which means that there are tools which are able to, so you've got a program, say you've got a Java program, think about your own old vehicle interface. And there are some methods out there, right? So there are some tools which will be able to convert that vehicle interface into SOAP messages, right? So if a client application is trying to get a vehicle and say vehicle.start, right? And so all this underlying messages are SOAP messages which are traveling via the enterprise service bus, and then that marshaled back via your tools into your objects, right? So it's somewhat similar to RPC, but your protocol is now HTTP, and the standard is much simpler. These are XML human readable messages, no longer binary messages, right? So that's a big difference between the implementation of a service-oriented architecture approach and the RMI approach, right? And also it's a shift in paradigm, it's a shift in thinking, that you're looking at your applications no longer as in silos, but as a set of services which can communicate their service over HTTP. So that was the thought process behind service-oriented architecture, right? And that eventually gave way to REST. So we'll spend some time on REST. So the full form of REST is a representational state transfer. Now that's quite a mouthful, right? So what it really means is, think of your system as a set of resources. Now, what does the word resource mean? So if you've done your course in databases, right? So you've got your primary keys of different tables, and they're holding the data of certain entities, right? So you've got wherever you've got a case where you're holding data which has got a primary key, and so that is a good candidate for a resource. So think about your web application, right? So you're a customer, you are logging in to your shopping cart application, and you're able to see your account and your past orders, etc. Right? So what would be the resources in this application? Your resources would be the account information itself. Your profile would be another resource, right? And your delivery address would be another resource, right? The list of orders are different resources. And if you think about how you would save these orders in your databases, right? So order will have an order ID, an order description, and other details about the order, right? So this kind of translates directly into entities being stored with the primary key in the database. It's pretty easy to map that. So visually, if you've understood this, okay, what I have as a resource in a system is something that is being stored in a system with a primary key. That is my resource, right? So then what can you do with that resource, right? So you can modify that resource. You can modify this, the state of that resource. So what does this mean? So assume that you are logging into your banking application like ICICI Bank, and you want to see your bank statement. So you log in and then you navigate, you click on the link, say, okay, view my bank statement, right? And then it gives you the option of looking at the bank statement online, right, as a table, or you can download it as a PDF or as an Excel sheet, right? So underlying in the database is just a list of statements, right? You've got different account transactions that have happened on some dates, right? Those are the actual resources. But the view of that resource could be simply as an HTML data. It could be a PDF or it could be an Excel file, right? So the state of that resource, right? It could be in it could be in different formats as a PDF file or as simple as an HTML table, right? And as you make transactions, there are additional accounts, there are additional holdings, that transactions that happen in your account. So the state of that resource is changing, right? So think of account as a resource, and your account transaction as a set of resources. And so every time you make a transaction, you are changing the state of that resource, right? So this is again a very different style of thinking from what we just talked about in the service-oriented approach. So view your web application as holding on as a server that has got access to a set of resources from the database. And you as a person operating from the browser, all you have is a browser, right? You navigate to a website and then you hit a URL and then say, okay, get me the landing page. And what does the landing page show you? Okay, you logged in, and then the landing page is showing you, if it's a shopping cart kind of application, right? So some items which you can search for and buy, and you're able to see your orders and account, etc. Right? So all these are resources that are provided to you by that application, right? And what you're really doing with your browser is clicking on those links, opening those resources, and either viewing or modifying them, right? You might be able to update your profile data, do transactions on the site and change the state of those resources, right? So if all you're doing is changing the state of those resources, then you don't need too much. What do you need? You just need to be able to get the representation of a resource, right? In terms of a JSON. A JSON is a simple text, human readable format, similar to XML. XML has got a particular schema, and the payload size is larger. JSON, you can see the structure here is very easy to understand. Right? So JavaScript again is a very popular and very commonly understood language by all browsers and by all platforms, right? So what could be easier than representing your resource in the database in a JavaScript format, right? So this is JavaScript object notation. That's what is JSON. And you can see here that a REST API could be, the implementation could be in one language, and the consumer could be in some other language. But what's really happening on top of it is just a URL request, right? And you're familiar with that. This is what happens over the browser. It's a simple GET request, right? You do a GET request. So if you've used the browser, seen what's going on underneath, you will be familiar with the GET request and the POST request, right? So let's look at this in some more detail. So what are the operations that are available over HTTP? Right? When you're navigating via a browser, what is actually happening under the scene, under the hood, is that your browser is making HTTP GET requests, right? And a GET request is all it's doing is, okay, just get me some data, right? I'm clicking on a link. Okay, here is a PDF file. I click on that PDF file, and it downloads that PDF file, right? That's all that GET is doing. It is not changing the state of the server. Nothing has happened in the backend. If you click on that link again, you will see the same PDF file again, right? So reading the data, it doesn't change the application state. Post, it creates resources, right? So if you want to create a new order in your shopping cart application, right? So you'll be filling out a form, right? You would have had the experience of filling out a form, an HTML form, It's got a submit method and it's got a text area. You put in some stuff, bunch of fields and hit submit. So when you hit submit, all you're really doing there is you've got an HTML form, and the form data is being submitted to the server as an HTTP post request, as a set of key value pairs, right? So I'm sure that you are familiar with this, right? And if you've done even a little bit of HTML programming, you will definitely know about get and post. But if you think about what is post doing in the backend, right? It is creating that resource in the backend. It's making some entries in the database. Not any entries, these are resources that are getting created, right? So that is the paradigm around REST, right? HTTP also supports two important methods called put and delete. Put basically updates the resource, right? So you basically click on a link, you see some order details, you want to make some modifications to it, right? So you can of course send back another post request, right? But in the REST model, that would be put. And of course, if you want to delete some resources from your application, you would use the HTTP delete method, right? So from the browser, it might not be visible to you that this is what is happening, but look how simple it is. You have basically 4 methods and available to you in HTTP. And this is all is really needed for different systems to communicate, right? So the simplicity of the whole makes it so. So this is the reason that has led to the wide adoption of a REST model. So the platform of communication, the protocol is HTTP, which is what the internet is running on. And the standard to communicate over the, what are you really doing there? You just have 4 methods, get, post, put, and delete, right? And this is enough to create resources, to get resources, and to update and delete. So this is called CRUD operations in the database world, right? Create, update, and delete. And this is pretty much sufficient for you to do 99% of all the work that goes on between different systems. This is really what you're doing, right? At a resource level, this is all that you're doing, right? So this is a pretty simple way to understand this. And so if you're doing your Codeathon exercises, and so I would encourage you to think about the objects that you're writing in terms of REST as well. So if you're developing the facility for other programs to consume your program, right? So you would probably need to write an API for that and expose it as REST services, right? So I'm sure you by now you really understood the concept behind REST, right? And what I want to next do is quickly talk about the authorization, right? This is, by itself, if we go into sufficient detail, this is material for a separate presentation in itself. But the concept again is fairly straightforward and very, very easy, right? So, so if you've logged into Hotstar or logged into any of these photo sharing websites, right? You will see that there is really no need for you to create a custom login into these sites. So these sites allow you to log in via Facebook or log in via Google. There's something that all of you, I'm sure, would have encountered. You download an app onto Android, they're already logging you in via your default logged in Android profile, right? But if you're doing the same activity on the internet, on a browser, right? So here's a screenshot. It says that you already have an account, you can sign in, or you can log in via Facebook, right? So what's really going on under the scenes here? So APIs exposed by these sites, Google or Facebook, are what is making this possible, right? And so let's take a slightly deeper look under what's really going on. So I've got only one slide here, right? I'll just give a very quick overview of what's going on here. So there are actually 3 different entities here. There is a user who's come onto a site and they're trying to log into a particular site. That site is your site, right? You're the application developer. We will talk about an internet site. We'll not talk about an Android app for simplicity. Assume that you've got a website, you've got a photo sharing site. And what that photo sharing site lets you do is users can log on via Facebook. And once you've logged on via Facebook, you will be able to see your different photo albums you have created on Facebook on this photo sharing site, photo printing site. So the users can go and say that, click on the photos they want to be printed. And these are photos which are sitting in Facebook, and say, go ahead and print this. right? And what is the site doing? That this is a site that you have built is able to download these photographs from Facebook, right? Because you have authorized it. And then the site is able to print it. So there are three different legs out here, right? There are three actors, if you will. So one is a user who is trying to access the site that you have built, right? And the second party is you yourself, that is the website, right? So you have built the website, and that is the second party. And the third party is Facebook or Google. So if we take a Facebook example, that's the third party, right? So each of these need to talk to each other, right? So what is happening is that the user is authorizing this third-party site that you have built, this photo sharing site you have built, to access some resources. Now think of your photographs as resources, right? The user is authorizing these the third-party site to access some resources on their behalf, right? So the website does not want complete access of your Facebook account. All it needs is that, look, I want access to some small amount of data. Firstly, login. Okay, first tell me that user is logged in, and then give me some small part of his data, right? That's what the website is requesting, but the user has to authorize it, right? So how does it work? The user will log in to, say, some application, your application, and then they are shown a small screen, which is actually login via Facebook. So once they click on that, a browser pop-up opens, which is actually the Facebook. If you see the address bar there, that's actually the Facebook address bar. But at the end of it, trailing end of it, it will also have some extra text around it, which actually points to your website, right? So what's going on here? The user will log into Facebook with some extra credentials, with some extra mapping URLs, which will say, okay, look, I'm logging into Facebook, right? But I'm logging in on behalf of this particular third-party application, right? And so once the request reaches Facebook, Facebook will send back a message saying that, do you authorize this third-party application? Do you give the permissions to the client application, right? And the user will say yes. Once the user says yes, what happens is, right, Facebook, so you would have registered with Facebook yourself. Like that's the first thing you will do. You go to Facebook and say, look, I am this third-party site that I need to access some resources of your users, right? So you will go to Facebook and do that first, and you will get a kind of an API key. Say, okay, here is a key for you. Whenever you come to me, you need to come to me with this particular key, right? So once the user has provided this permission, right, and then there will be a browser redirect, and the client application will be given an access token, right? So that's the most important thing here. Okay, the client applicant say, okay, here is my API key, and here is this user who is logged into Facebook, right? Now give me a client access token so that through this token, I'm able to access the user's resources, right? And Facebook will see that, yes, this is a valid application registered on Facebook, and the user has authorized it. Here is an access token, right? And now what's going to happen is that this third-party site that you have built will be able to access the limited set of resources which the user has provided authorization for. So in case of if they've authorized you to access their photographs or the photo albums, the client application via Facebook APIs will be able to say, okay, get me all the photographs, photo albums of this user. But while making that call, they will have to pass the access token, which was issued by Facebook itself. It says, okay, here is a valid site which is registered here, and the user has given the authority. Okay, and here is a valid access token. So this is the third step, and so here are the photo albums, right? And then finally the response goes back, and the website displays those photo albums on the site, right? That's coming from Facebook, right? So this is this is called a three-legged OAuth. And so if you're going to be doing real world API integrations with third parties like Google or Facebook or any other payment sites, right, or government websites, this is the first thing that you will encounter, right? And this is it's a well documented and fairly easy to understand, right? It's slightly involved because there are 3 different steps, right? So it's a very exciting and very interesting to understand as well. right? To if you want to showcase your knowledge of how APIs work, this is really it, right? So the OAuth and the three-legged OAuth authentication authorization, right? So I wanted to talk about this, right? So this is pretty much it actually. So my talk it came up to this point, and I wanted to give you an overview of what APIs were and where is the industry today, right? And REST APIs, as I said, conceptually it's very easy to understand. Just got a few set of methods which HTTP itself, exposes, and the different systems can talk to each other via these REST APIs, right? And I want to show you a slide. So this is what we do in American Express, right? So there are different fraud prevention APIs available, right? So there's just a small snapshot I've taken of developer.americanexpress.com. You're welcome to take a look at it, right? So American Express in the card business, it deals with the card business, and we engage a lot of third parties, right? So interact with a lot of third parties. Typically, there are merchants, right, large and small, that integrate with American Express, right? So there are a lot of APIs that are available in different domains. So in fraud prevention, for example, so assume that you're a large merchant and you're accepting American Express cards, right? So say online, and so there's a way by which you don't need the users to type in their the American Express credit card number, which is which can easily become insecure, right? So there are ways by which you can get some kind of a payment token from American Express, right? That will help you reduce the risk and reduce chances of fraud, right? So open banking are a set of APIs. The word banking itself suggests so that it's large institutions, if they want to integrate with Amex, right? So it's an open banking interface, right? And payment services, again, it's for merchants that you're a small merchant, you're just a developer, right? And you say you're accepting payments on your app, and you want the users to be able to accept American Express cards on your site. So you would head for the payment as a developer of the app, you would head over to the payment services. So if you want to provide some personalized services for customers, etc., you can go ahead and take a look at that. But as I said, so all of this is very specific to the card industry, specifically American Express, and most of it is integration via merchants and banks, right? But you can take a look at how API integration plays a very key role for American Express to be able to reach out to its third parties, right? Without it, it's impossible for merchants to be able to easily integrate with American Express. So you can see that for large enterprises to run successfully and be competitive, it is important for them to expose their key functionality both within and outside the enterprise as a bunch of APIs, right? And it is this need by these large enterprises that has really driven all the technology and innovation around this, and simplified the whole communication platform, and made it, there's a lot about security as well, right? So even the security principles are fairly easy to understand, right? And so this really is the journey so far, right? So before I go, I want to show you one last slide about what is really happening, the bleeding edge of the world of communication technology. So Google is pretty heavy into RPC technology. They use it internally for many years, right? So we talked about RPC, remote procedure call, and where the messages going from one system to another, right? They're binary messages, they're not text messages. So you will be able to make a call to a remote system as though you are calling it locally. So that is the guiding principle around RPC. It's a remote procedure call, right? So Google is pretty heavy into it, and they have this technology called proto buffer, which is a binary format, again, which is used over HTTP2, right? So here is a critical point. Most of the internet is running on HTTP 1.1. So internally, so this is very popular. It's currently being used and being tested and tried out even by American Express, right? But this is you will use this where performance is the most important thing, right? Because if you're to think about your JSON message, it's text format, right? So what if you were to compress that message into binary? That'll just be it'll get compacted down quite a bit, right? And if you had tools that could compress that message and transfer that message over HTTP, right? And then you had the necessary tooling to be able to unmarshal the data back into objects in your respective programming languages, right? So this is what Google has done, and they have open sourced this technology, protobuffers, running over HTTP2. And so if you really want to, showcase your skills in what's happening in the latest in industry, this is again a good topic of research and to understanding. This is very well documented, and it's fairly high on the adoption as well, right? And I would really encourage you to take a look at this as well. Most of the Google APIs are available as gRPC even today, right? So you've got the REST version, you also have the gRPC version if you go to Google. And that's pretty much it, really. And so I really encourage you to hack away. And I know you're working on your Codeathon exercise, right? Keep a larger perspective and see, okay, if I need to open out my functionality to the world, how will I do it? Again, REST API should do it, right? If I need to integrate with existing third-party systems, how will I do it? Again, it's REST APIs. So I would really encourage you to study REST APIs. It's very simple, right? And if you're feeling really excited about the journey, go ahead and look at gRPC as well, and see what excites your interest. Right. So that's all from me today, right? So are there people on the bridge who would like to ask questions? You can, I believe you can even type questions out, or if you want, you can ask questions as well.
Shadri Maggie here. Students on the call, if you have any questions, feel free to ask in the next couple of minutes. Looks like we can close. Suchi and Shadri, thank you so much. That was a very informative session.
Okay, thank you.
And the information on the HTTP2 and how that is currently beginning to take over the world is very informative, and we really encourage students to pick up on that and do their research. Thank you so much for sharing so much insights, and we really appreciate you taking the time to do it. And again, thanks to American Express for supporting this initiative.
Yeah, Maggie. Yeah.
Sure. Thank you, Maggie.
Okay, thank you.
Yeah. Bye.
Bye-bye.
Yeah.
Online, they didn't.